Thanks for coming. Okay, today I'm sorry, I'm just lead a little bit to the title, so well, the sense is the same. So discovering the power of graph databases with Python and Neo4j. Just a few lines of outline, just a few words to present myself, and then just going through some basic stuff about graph databases. And of course, Neo4j, is there someone who already have something to do with Neo4j here? Okay, few. Okay, cool. So I would like to spend at least half of the talk just to introduce the technology, and then the last part where I will dedicate of course, to the interaction with Python. So who am I? I'm Fabio. I'm coming from Treviso, and actually my career was a little bit bizarre in some sense. I started I'm a civil engineer. Transportation engineer, actually. So I started to play and work with trains, Lego trains still, and everything that is around transportation networks and mobility. And last year I had the lucky to know Larus, which is a company based in Venice, or Venezia, which is the main partner in Italy of the technology of Neo4j. So I was involved in this adventure. And now I'm trying to share with you this experience. And also I'm enjoying the Database Venice. I'm behind the organization, so don't miss tonight the event at 7 here around the conference. Larus was born in actually 2004 in Venice, and now is the main partner of Neo4j. We are also sponsoring the conference. You should find a little flyer on your bag. So actually this is a little spoiler alert. So Larus supports Python, which is this basic Python script which deserve a little bit of Cypher, which is the query language of Neo4j within the code. So this is the bad guy of today. So databases. Actually, where today the difference between logical stuff of developing databases that sometimes, or better, most of the time, in my experience, we're actually dealing with relational databases, so a lot of tables. But the problem starts when we are trying to discover connections between data. So actually, we can also in relational databases, but we have to do some joins and going deeper and deeper and deeper with the lack of performance, of course, and sometimes with a lot of time consuming. So actually, the natural transition from relational database to the NoSQL world. Actually, in the middle, we have some examples of NoSQL databases, the documental, for instance, maybe for MongoDB or Couchbase, to column technologies like Cassandra, for instance. And the NoSQL, so the graph database is actually the last category of NoSQL databases. And the big difference here is that actually we have the connections within the database, so persisted actually in our storage. This is the great advantage because actually we just have to model in the right way the information, and then just to read everything which is already stored in our database. And connections actually nowadays are the main goal of all the things we're trying to discover from data. So it's a big thing having so this kind of familiar and very powerful technology to discover and all the information within our data. So Neo4j actually is a graph database actually. Okay, nothing to surprise. But from now on, actually the technology is trying to develop a full platform for connected data. We have the Neo4j, the database in the middle, but actually the company now is trying to discover everything from data integration to data analytics, data science, and everything that surrounds the database. So actually this is the main platform that is going to be developed. Neo4j and all graph databases are also very helpful to glue data coming from different sources, from different kind of databases, from relational to key value or whatever. and everything, to sum up, everything in a whole single Neo4j database with everything structured as nodes and relationship. And since we are talking about graphs, if you are familiar with common complex networks, law, network science stuff, so everything that comes from the small world phenomenon to the scale-free properties. Actually, since we are working with databases, with graph databases, so graph is a network in some way, and so everything that you know already on graph theory, on network science, you can apply everything just one-to-one to our graph database. So it's very powerful. And remember that in graph databases, we are matching patterns of information. So actually, the goal here is to go within a single point in our model of information. We have an index here just to point directly in the more fastest way, and then just navigate the database from this starting point, the so-called landing node, and then discover your pattern. So this is the main property of Neo4j in the graph databases. But Neo4j has a particular property, which is a native graph database. What does it mean? It means that actually we have this index-free adjacency property, which is actually very helpful. And what does it mean? Actually, we have all the connections we model in our graph. All nodes in the database already point to its success node. So actually, everything is already stored in the graph mode, already in the storage, both in the model, both in the storage. So actually, the cost of traversing one node or 1 million node is the same. It's the same cost and the constant value in terms of time. So let's introduce how we can model our information in Neo4j. At some point, we have some basic information to model. So we can just put main entities into nodes. We have 3 kind of nodes: person, city, and event in this way. We have some properties to characterize better the information, so the name, for instance, the type, the conference, and then just connect our nodes, so our main entities, through relations. Logs, dog set, located in. This is the first model of a potential graph database. Actually, it's very easy also to build and query. Cypher is the query language of Neo4j. It has been developed within Neo4j, actually, for Neo4j and within Neo4j. This is going also open, just to open access in some way, and just to go a little bit further with other technologies, since it's very simple. I think that you can just with this. If you are going to write this line, it creates, Neo4j creates with Cypher the full pattern of node, relation, and the second node. So everything we have to model here has been written here in Cypher, and has been actually saved into our database. The main entities are the label, actually, which define the category of the node, and properties which enlarge the meaning of the entity. So some applications before going on with Python. The recommendation is one of the most potential and actually famous application of Neo4j. This is a simple Cypher code. I think that even if you're not familiar with that, you can just recognize the full pattern. So the basic recommendation system: I buy something, some other person buy the same thing, and at the same time buy some other thing, so the thing that I should be recommended with. And you see that actually matching this pattern, just going back and get me the recommendation thing, which is the my main interesting result. And second application, I think that maybe you already know about that, the Paradise papers. So a consortium in US, I think, collect a lot of, last year I think, collect a lot of information from a lot of different sources, databases, etc. And model everything in Neo4j just to find out all the potential relations and within properties in the Cayman Island, etc. And in this example, for instance, we have the if you are going to match the duck here of Lancaster, which is actually the Queen Elizabeth private estate in this node, actually we are able to select everything on one side and everything on that side, on the other side. Just this means that, so this means that we are going to point the first node of the Lancaster node, going up to 2 steps beyond, and get everything we have on the other side. So actually we can, in this way, just have a full image of the connections, potential connection from the whole system. Okay, this is a brief. This was a brief introduction to Neo4j. Actually, Neo4j is very easy to call and to query within Python, of course. We have an active and official Python Bolt driver in Neo4j. So Bolt is a super fast protocol, communication protocol, developed by Neo4j from version 3.0, I think. So we have the Python official driver, but also the Java, .NET, etc. And it's super fast to communicate from Neo4j with Python in this way. So let's see how it works. For instance, this is you can just install with the pip install Neo4j driver, and we have to point to our location, just get basic authorization user and password, and then start our session, and you see that you can embed directly the Cypher code within Python. So in this way, we have the same. If you are running this Python script, we are getting out the pattern with Fabio talks at Python, so node, relation node. Actually, everything we can query through Cypher in Python is a Python thing, directly. So actually, in this way, for instance, we can match something. So myself talks at some event and get all the results as a pandas data frame, which is very useful. I think everything for getting results back and actually work with pandas later. So this is the basic interface from Python to Neo4j. There are also some tips and tricks in data importing phase, which is very important. In this way, actually, Neo4j can read or can import different kind of files from JSON to other data from other relational databases. But sometimes also in my experience, the most familiar thing you can import is simply CSV file. But you have to take care of the format of this file before proceed with the import phase. For instance, we have an active procedure in Neo4j which can easily load up to 10 million records in a single transaction. But here are some tips and tricks. So actually, you have to format a little bit your CSV file, the bad one, at the beginning. Some tricks are actually take care of no punctuation and no spaces in the headers, because they are the main information that you later pass to the Cypher code. And also is not well, actually is recommended to also to parse a little bit the types of the data you want to import in advance. So at the end, you can just read, do some stuff, save back your file, and imagine that this is the file that I want to import in Neo4j. This is the Cypher code that allows me to import the information. You see that it's pretty easy. Just read the file, just create. This is the first node with the properties that I'm going to read through from the headers of my CSV file. Create second node in the same way, and directly on the fly create also the connection between the two entities. So it's pretty easy. Just be aware of the passing in the right way through with pandas, which is very useful in advance your CSV file. If you have more than 10 million records, actually there is another technique, which is the so-called bulk loader in Neo4j. The difference is that the load CSV, the previous technique, reads and write through transaction. This backloader actually read the CSV file and write directly in the database format, which is actually very fast. But still, there is some pre-processing to do. In particular, we have to take care of the headers, because the backloader needs a proper header of the file you want to upload. For instance, this is related to nodes. So you have to select the first column with an ID, and then this continues with all the properties that you want to introduce in your model, parsing also directly here the type of the information, so integer, float, or whatever. And at the end, you can also specify the label you want to assign to each information, or each record, or rather each node that you want to create. The same for the relationship. So now we are going to create only the nodes. For the relationship, again, we have to take care of the header of the column. Just select the start ID, the end ID, even actually also some properties if you want to associate with the relationship. Sorry, and the type of relation. The type is the so famous loves talk to. That's the type of the relationship. So actually, one for the node, one for the relationship, or better, not one, but many files as the types of nodes you want to create. So for instance, at the end we can produce 3 types of files for this example. So the file that loads the person entity, the file that loads the city entity, and the file that actually match everything that I already created as a node, and create the corresponding link relation. And this is the procedure that it's called Neo4j admin import. It is within the bin folder of your Neo4j installation. And actually it's very fast, because actually you just read the proper formatted file and writes everything in the database format. Actually, there are some. This works well, or actually not well, but this works only with the empty databases, because you just create everything and that's it. But if you want to actually update your information, it's better to use the load CSV, because you can just select maybe also the information that you already have in your database and create only the missing part. So usually, a good technique is to use this tool to write everything in one shot, the big thing, and then use the load CSV just to update or select some part of the database you want to update. So this is everything official. Actually, the developer which developed the official driver of Python in Neo4j also developed this external package. It's called Python Neo. This is an extension of the Neo4j official driver, actually, but it's in my opinion it's easier, and it has also some more potential, and because also supports pandas data frame natively, which is a very good thing, and also now we are going to see some good stuff that you can do with it. So for instance, just again pip install Python Neo. It's very easy. So in this way, we can just import the package and create our 3 nodes, so ABC, okay, with the label and the property that you want. Just create the relationship from 2 nodes, okay, and you see that you get back directly the Cypher code that represents actually the node link node relation, or actually model pattern, okay. And again, you can also create multiple relationship within Python Neo. There are also some cool stuff. For instance, if you have 2 patterns, you can also perform the union or intersection. Getting as a result, we have a dictionary with all the nodes and all the full pattern that you want to get out from your query. And this is also really nice, the so-called workable type in Python Neo, just going into the command line and put everything that you want to concatenate in some way of your database. And we have this pattern already in our database, but think that you have to create another relationship that doesn't exist already in the database. A new relationship between two more nodes. And yes, Python Neo has native support for pandas data frame, which is also very easy and useful. And you see that you can just connect to your database instance, just perform a query here with the Cypher, and get back the result as a pandas data frame. This is very easy and useful because you can just extract some information, do some stuff, and then also get back to Neo4j with adding some more properties that you can calculate within pandas here. Last package, this is called Cypher, and it's brand new actually. And it's interesting because you can express Cypher queries in pure Python. What does it mean? That actually, imagine that we have this simple query, which means that just want to find the person which has the Twitter account, my account, and you see this is Cypher, this is Python and Python, okay. And you see the difference is that, well, it's not difference, but you can just express here the syntax, the Cypher syntax directly within Python in this way. So just perform the match node where property is equal to, okay, and get back with the result. This is actually useful because sometimes you get just getting crazy with the nested quotes, or when you have to find something related to strings, which is might be a pain. And this is useful because actually you can just perform everything in pure Python, and well, sometimes it might be helpful. You see that also in this way we just can print our Cypher Python, sorry, command, and get back directly the same information, or better, the same query in Cypher. Okay. Okay, I was pretty fast actually. So summing up, Neo4j. So just a brief introduction of the technology. We'll see that we have seen that actually Python is very useful in both in data preparation, but also in input-output operations, thanks to the official driver and many packages that have been around for a while. And I think that more are going to come. Since I have some more minutes, and let me, okay, thank you everyone, and also some more thing, because if you are interested in collaborating and, well, first knowing a little bit well the technology and Python, I'll be around for all the conference till Sunday, so catch me up, no problem. And also one more thing, if you want to also to work with myself, or actually with Larus, within Neo4j projects, also in the development of all the platform that we already seen at the beginning. Just count on me, okay? See you around, and okay, I think that sorry, it's okay. Sorry, I was pretty fast.
Okay, thank you. So, you are very in time.
Yeah.
Thank you. So there is time for answering questions if you want. Any question? Okay.
Hi.
Hi.
Just two questions.
Yep.
First one, do you have multi-master replication? And second one, what about an async IO compatibility? I mean, not just waiting for the read flag set to 1 by the kernel, but having some kind of API that really talks with the Python driver, telling, yes, we started writing on the socket, but we also finished writing on the socket, which I think is something unique to Postgres, maybe. Because usually with async IO, you read something from the socket and wait, or keep reading till the read flag is set to 1. I don't know if you use async IO or something like that.
Okay, I'm sorry because I'm not pretty familiar with these super deep things.
The idea is the Python driver somehow can know by looking at the socket, dealing with the Linux kernel, the Windows kernel, whatever, that the data right on the socket is completely done or is still running.
Okay, I understand. Actually, yes, this is a property of Neo4j. Actually, Neo4j is full ACID, so actually all the transactions performed within drivers, API, or whatever, actually are as well full ACID. So actually everything is consistent in the database and reading and writing things. Okay.
And for the multi-master?
Yes. In what sense, multi-master?
Do you have a multi-master replication?
Okay, so this is about the technology. Yes, we have actually, if I remember well, so Neo4j can scale in. We have two architecture of clustering. Actually, the more recent one is called causal cluster. So we have all servers and replicas around. And the other is the HR, so high availability, but it's getting a little bit older in some sense. And so these are the two techniques of clustering in Neo4j. And well, that's I don't know if I answer actually your question, but.
Here.
Hi.
Yes, please.
Thank you. I have two questions for you. The first one is about licensing, because if I well remember, Neo4j has two licenses, a community edition and a professional or enterprise edition. Are these functionalities all supported by the community editions, or?
Yep.
Okay.
Yes, the basic functionality are common from with the community and the enterprise. The enterprise has some more things more than the community. For instance, all the backup system, the automatic backup system, and all the role administration of users. Which actually in the community edition you have only you can create only one user that is administrator, or better, many users, but actually everyone is the administrator of the database. In the enterprise, you can select and more roles actually in the whole system. Yeah.
And the second question is, we are pretty used to use OrientDB instead of Neo4j. Actually, I saw some functionalities that I'm not sure that actually exist for OrientDB, but we're pretty fine with that. The question is, why would you suggest Neo4j for a typical OrientDB user? I mean, what is, in your opinion, the strongest point against OrientDB, for instance, by Neo4j?
Well, in my opinion, I think that the native thing that we saw in the middle of the presentation, so the thing that the index-free adjacency, it's a very good point. So actually, everything is stored in a database with the respect of the relations. So actually, transversing the graph, it doesn't cost anything to Neo4j. This is a good point, I think.
Yeah.
Okay, thanks. Okay. A question over there.
Okay, so in the examples you showed us just one-way relationships. Are there a kind of or
Yes.
Can you?
Actually, I showed only one way because for definition, Neo4j accept actually the only one direction, or better, sorry. Every connection within two nodes has to have a direction. So if, for instance, Fabio thanks PyCon is okay, but if you would like to model also that PyCon thanks me, you have to write the same relationship, but on the other side. So, I mean, the thanks relationship can exist in both directions, but you have to model twice. So one
you have
in
to
one
do it
side.
manually.
Sorry.
You have to do it manually.
Yeah, in the modeling phase. Yeah. But this is only for writing. Actually, when you have to deal with bidirectional links for writing, they have to have the proper direction. But in querying, you can also just tell Cypher, okay, get me every relation, no matter the direction, no matter between two nodes, for instance.
Can you also query for, give me every people who thanks PyCon, for example?
Yeah, yes, it's a very simple one. Yeah.
Okay. There is another question. Okay, this guy.
Small questions. Are there some native algorithms or packages for text processing?
Text processing. Well, there is a big package called Neo4j Epoch, APOC, in which you can find more than 400, if I remember well, functions that extends actually the native functionality of Neo4j. Text processing, do you mean?
Yeah.
So NLP, something like that. There is something not actually pretty native. Native is only some basic stuff like the ends with, the starts with, contains, actually related to strings, but not yeah, NLP related in fact, somewhere. Yeah.
Okay. Yeah. Thank you.
Usually, this kind of stuff, you can just also connect Python to do all the NLP stuff in one side and then reverse everything of what you need within Neo4j.
Okay, thank you.
Thank you.